All right, today we're starting section 5.2, use perpendicular bisectors. So that term is something that you have seen before. It was used on that blue sheet that we were using to help us do our proofs. Some people wanted to use it when really we hadn't talked about them specifically yet. We had talked about perpendicular lines. We had talked about bisectors, but now we're going to put them together. All right, first warm up. How do we solve that equation? Taylor? Sure. What else did you do? Okay, we'll go ahead and do that all at once. What does that leave me with? 17 equals what? 2x. Last step? Divide by 2. I would be fine if you left it as 17 over 2, or as a decimal, that would be 8.5. Do not give me a mixed number. I'm fine with a decimal that terminates. I'm fine with an improper fraction. No mixed numbers. Questions about number 1. If m is the midpoint of AB, AM equals 5x minus 2, and BM equals 3x plus 6, find AB. It might be helpful to have a diagram drawn for this. It might be helpful to draw yourself a diagram for number 2. Not essential, could be useful. We've got a segment AB with a midpoint of M, and they gave us AM and BM. So before we can find the length of AB, it would be helpful for us to solve for what? X. In order to solve for x, we need an equation set up for that. What equation could we set up here? Good. 5x minus 2 is equal to 3x plus 6. To solve that, what do I need to do? Subtract 3x on both sides. We can also do what? Add the 2 on both sides. What does that leave me with? 2x equals 8, so x would equal 4. Are we done? Nope, we still need to find the length of AB, so what are we going to do? Plug it into what? Where? Okay, you could do both of them, or you could do one of them and then multiply by 2, so it doesn't matter to me. So if we just find the length of AM, 5 times 4 minus 2. Okay, so if AM is 18, then AB is 36. Questions, concerns about that? Okay, we'll move on. Recall that a segment, ray, line, or plane that is perpendicular to a segment at its midpoint is called a perpendicular bisector. A point is equidistant from two figures if the point is the same distance or length from each figure. Points on the perpendicular bisector of a segment are equidistant from the segment's endpoints. which we're about to talk about that more. Okay, so remember, for it to be a perpendicular bisector, it has to satisfy two things. It needs to be perpendicular, which means it forms a right angle at the midpoint. So it has to be both perpendicular and bisect at the same time. So we have a theorem that says in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So in that diagram, what is our perpendicular bisector? CP. Line CP is the perpendicular bisector, so if you want to make a note of that, you can. CP is the perpendicular bisector. Of AB, if we want to be really segment AB. Want to be specific about it. So CP, line CP is the perpendicular bisector of segment AB. So because C is on the perpendicular bisector, that means the distance from C to A has to be the same as the distance from C to B. So these are congruent. Or you could write a statement about it. AC is congruent to CB. Okay, keep in mind that those, I guess I should use 2 tick marks instead of 1 there since they already used 1. Those were not initially part of the diagram. I added those because that is the conclusion that we can draw from this theorem. Questions or need more time on the perpendicular bisector theorem? Okay. Next up is the converse, which means we go the other way. If a point that is equidistant from the endpoints of a segment then it is on the perpendicular bisector. So this time they gave us a different point that was equidistant. So if point D is equidistant from those endpoints A and B, then we could conclude that D is on that line segment, or that line CP, because that is still the perpendicular bisector in this case. So we would know for sure, even though it looks like it, we know for sure that point D would still be on this line. That's the perpendicular bisector because it was equidistant from those endpoints. Questions about the converse of the perpendicular bisector theorem? BD is the perpendicular bisector of AC. We are asked to find AD. This is going to be a lot of repetitive thought processes and then a lot of algebra, so that should hopefully make this an easy section. If BD is a perpendicular bisector, then point D has to be equidistant from the endpoints A and C. Okay, D is on the perpendicular bisector. It has to be equidistant from points A and C. So we could mark those congruent, which means we could set up what equation? Wonderful. 3x plus 14 equals 5x. To solve it, subtract 3x from both sides. 14 equals 2x. Last step. Divide. X equals... Are we done? No, they wanted AD, so we need to plug it back in. Good. AD 5 times 7 gives us 35. Questions about example 1? Okay. Example 2. Why don't you go ahead and try that one on your own? It's very similar to number 1. Remember, we've got R on the perpendicular bisector, so it needs to be equidistant from those endpoints, P and Q. So we set up our equation, we find X. The last thing to do is plug it back in. Does it matter which one of these I plug it into? No. Technically, no, because we already said they should be congruent. So in my case, or in my opinion, I think it's easier to plug it into the 6x if you plugged it into the other one. That's not wrong. Either way, what should we get for the length of PR? 27. PR should be 27. Yes, ma'am.
Can you solve this?
The equation?
Yeah.
Sure. A couple ways we could do it. To keep my variable positive, would subtract the 6x and add the 9. So that means that there's 2x left over here. The 6x's cancel out, so 2x equals 9. Divide by 2. That gives us x equals 4.5, 4.5. Other questions? Okay, we'll move on. In the diagram, line JM is the perpendicular bisector of segment HK. Which lengths in the diagram are equal? There's the obvious one. Which one's obvious? Okay, LH and LK, they wrote those on there for us. LH is equal to LK. Notice that I'm not putting the bar over them because I'm using an equal sign, not a congruent symbol. That's one of them. What's another one? HJ and KJ on the other side of the perpendicular bisector. There's one more. Good. We have a perpendicular bisector, which means that that segment itself is getting bisected. So HM and MK would have to be equal to each other. If you wanted to put congruence marks in the diagram, you can. Questions about 3A? Okay. Is point L on line JM? Yes, why? Anybody have an explanation? Akira? Equidistant from? Good. Equidistant from the endpoints. L is... You could just say equidistant from H and K. Those are the endpoints. Or you can just say from endpoints. H and K. All right, we know it's on the perpendicular bisector if it's equidistant from the endpoints of the segment that got bisected. Questions about example 3? Okay. When 3 or more lines, rays, or segments intersect in the same point, they are called concurrent. Lines, rays, or segments. The point of intersection is called the point of concurrency. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. Okay, there is a lot going on in this diagram. Okay, we have a triangle for one. We have all the perpendicular bisectors sort of being shown. The reason they are not fully shown is that they would then get in the way of us showing the point of concurrency being equidistant from the vertices. Okay, so all of these segments like DP, we could extend that line. EP could be extended. FP could be extended. That does not mean, for instance, that point B has to be on the same line as FP. That will not always happen. Since this looks like it's probably an equilateral triangle, it's going to kind of appear that way. But what this is saying is that this point where all those perpendicular bisectors meet, right here in the middle, is going to be equidistant from all the vertices or all of the corners of the triangle. So it might be easier to write it out in statement instead of drawing it and adding more to that diagram. This is saying that AP is going to be congruent to BP is going to be congruent to CP. We could draw them in, but again, it's already a pretty busy diagram to be adding more to it. This is different from the medians that we talked about yesterday, even though we're still dealing with midpoints here. Remember our mid segments that we talked about would have connected like D and E and F together. Questions about point of concurrency for perpendicular bisectors? Okay, throughout the rest of chapter 5, we keep talking about these different segments inside of triangles and how they're special, and then we have to be able to keep all their different properties straight. So I would make sure that you're keeping up with your notes and keeping them organized. All right. You should have your homework from that little slip of paper. Before you get too far into that, there is something else I'm going to pass out. And it is your first final exam review.